Hello everyone, welcome to MemoNeet. This is Aprajita, your chemistry SME. So I hope all of you are doing good, students. So today we are back with another video lecture. So now you will be appearing for BPT10. So I hope BPT9 went well and you people were able to answer all the questions. So all the chapters that have been covered till now but were asked in BPT9. So I hope all of you performed well in that, and now all those chapters are pretty clear to you. So now let us move on to the next part, means we will be starting with our next new chapters now. So the chapter that we are going to start is equilibrium. Okay, so it's an important chapter again, because a lot of questions again are asked from this chapter in your NEET examination. And apart from that, for your conceptual knowledge of equilibrium and all of that, again this chapter is very important because these concepts will be further used in other chapters also. So that's what we are going to study today. That is, this is our first video lecture for the chapter equilibrium. So we'll be trying to cover it within 3 video lectures. Okay everyone. So as you know, our MemoNeet sale is going live on 14th and 15th August. So please go through that and purchase the products for your well preparation of NEET. Okay. So the prices are lowest as of now in this sale. So make sure you are using or make use full use of that sale. Okay. So we will be starting with equilibrium now. So in equilibrium, the very first thing we will be discussing is the meaning, or what do you understand by equilibrium, right? So we'll be studying about meaning of equilibrium, ki what does equilibrium actually stands for. Okay, then we will be talking about the differences, or you can say different types of physical and chemical equilibrium. So this is for our today's lecture. We'll be talking about physical and chemical equilibrium. In chemical equilibrium, we'll be talking about the dynamic equilibrium. Okay, then we will be discussing the equilibrium constant and what is the expression for the equilibrium constant. Okay, the values of Kc, equilibrium constant, and Kp also, that's what we will be learning today. Okay, so make sure you are having your notebook and pen ready to take down the notes as well, because this is an important session, because all your basics for the equilibrium will be covered in this particular session. Okay, so we will be starting now, students. So as I told you, firstly we need to understand what is the meaning of equilibrium. So if I am talking about equilibrium in general way, I'm not just talking in terms of chemistry. So here, if we talk about equilibrium in any reaction or in any process, it represents a state. So a particular state it represents when the observable properties such as color, temperature, pressure, concentration do not show any change. So the word equilibrium actually means balance. Okay, literally it means balance. So when the things are balanced, nothing is undergoing any change. So in a chemical reaction, when we are observing any properties, be it color, temperature, pressure, so when they do not show any change, so that particular point or that particular state, we will be saying that now our system is in equilibrium. Okay. So here equilibrium in a chemical reaction means a balance between the reactants and products taking part in the reaction. Okay, not just for any chemical process, but equilibrium can be noticed in physical processes also, like melting of ice. You know that ice starts to melt at 0 degrees Celsius. So we will say that at 0 degrees Celsius, both ice and water are in equilibrium with each other. Okay, so that is the difference. Now in case of physical processes like melting of solid, dissolution of salt in water, the equilibrium is known as physical equilibrium, while the equilibrium associated with chemical reaction will be known as chemical equilibrium. Okay, so we'll be studying about both of them. So just now we are understanding the meaning. So meaning is that it represents a state of balance. Okay, let's take an example. For example, when any liquid evaporates in a closed container. Okay, so what happens during evaporation, we have already studied. The molecules which have relatively higher kinetic energy, they escape into the vapor phase. From liquid surface, they will escape into the vapor phase, and the number of liquid molecules from the vapor phase strike the liquid surface and are retained in the liquid phase. See what is happening, that the molecules having more kinetic energy, they are escaping into the vapor phase. But the molecules that are present in the vapor phase also, they are striking the liquid surface again, and they are converting back to liquid. So it means that certain number of molecules are going into vapor phase, and again a certain number of molecules are coming back to the liquid phase. So we will say ki an equilibrium will be attained when there will be equal number of molecules leaving the liquid and the number of molecules returning to the liquid also. जब वो equal होगा, right, the number of molecules leaving the liquid and returning the liquid are equal, so then we will say that a state of equilibrium will be reached. Okay, so that state is an equilibrium state, but that is not static equilibrium. It doesn't mean ki nothing is happening. Static means ki everything has stopped. No, the process is still going on. Okay, there is a lot of activity going on between the boundary of the liquid and the vapor. Okay, it's just that, so this is your vapor phase, this is the liquid. So boundary phase, still the molecules are getting interchanged. It's just that the number of molecules that are getting exchanged are equal. Okay, they are equal. Number of molecules leaving the liquid phase and coming back into the liquid phase are equal. So that's why we can represent this as the equilibrium. So equilibrium ka sign is these arrows we represent. It means the reaction is taking place in both the directions. So H2O from liquid to H2O to vapor. Okay, so this is a double half arrow that we are using. This we will be using in this particular chapter for equilibrium. Okay, and the mixture that we are having in that equilibrium state we will be known as equilibrium mixture. So उस mixture को हम बोलेंगे equilibrium mixture. Okay, right. So now let us move ahead, and now let us learn a little bit more things about equilibrium. So as I told you, equilibrium can be established for both physical and chemical processes. Okay, so reaction जो है, it can be fast or slow depending on your experimental conditions and the nature of the reactants. Now let's say if a reactant is taking place in a closed vessel at a particular temperature to give product. So what will happen? Concentration of reactant will keep on decreasing because they are just reacting with each other to give product, and the concentration of product will keep on increasing. Okay, but after some time what will happen? There will be no change in the concentration of either of the reactants or products. So in that case we will say कि the state of this system is dynamic. So try to understand the difference between static and dynamic equilibrium. Dynamic equilibrium means that reaction has not stopped, reaction is going on. Okay, reactants are combining to form product, but what is happening, that product is again you can say converting back to the reactant. So the equilibrium will be attained when the rate of forward and backward reaction will be equal. Okay, so this is known as dynamic equilibrium state. So if the rate of forward reaction and backward reaction is equal, there will be no change in the concentration of the species present at equilibrium. Okay, so in that case, up to which extent the reaction has taken place, we have three types of chemical equilibrium, means three extents we will study. That the reaction that nearly proceed to completion and only negligible concentration are left. So if the reaction has completed, so it is not even possible to detect that experimentally. Okay, so again the next one is reaction in which small amount of product are formed and most of the reactant remain unchanged. And the third case will be where the concentration of reactant and product are comparable. So that's what we are going to focus on. When the concentration of reactant and product are comparable, means when the system is in equilibrium. Okay, so this is what we will be learning in our this chapter, that is about the equilibrium. So let us first start with the equilibrium in physical processes. Okay, then we will be moving ahead with the chemical processes. So in physical process we have first solid liquid equilibrium. Solid liquid equilibrium means when your ice gets converted to water, liquid water, or you can say water in the solid state is getting converted to water in the liquid state. Okay, for that, now try to understand, we are taking a perfectly insulated thermos flask. So you have studied thermodynamics, so you know thermos flask is an example of a closed system. Okay, closed system means there won't be any exchange of heat, or you can say it is an example of an isolated system कि यहाँ पर there will be no exchange of heat as well as no exchange of mass between the system and the surrounding. Okay, all right. So at in this thermos flask at 273 Kelvin, means of course at 0 degrees Celsius and 1 atmospheric pressure, the ice and water are in equilibrium state. Okay, so what will happen? The mass of ice and water will not change with time and temperature is also remaining constant. But still we will say that equilibrium is not static. Why? Because at the boundary of ice and water, what will be happening? Some molecules of ice are converting into water and some molecules from the liquid, they will collide against ice and they will convert back to ice. Okay, so that process is still going on. That's why we are not saying it's a static equilibrium. Okay, but there is no change in mass of ice and water. Why? Because the rate of transfer, okay, the rate of transfer of ice, or you can say molecules from ice into water and water into ice, will be equal at this particular temperature. Okay, so you, that's why you have studied also na कि at this temperature melting will start. क्योंकि यहाँ पर what I told you in the starting कि ice and water will be in equilibrium. Okay, so they are at equilibrium only at particular temperature and pressure, not at all temperature and pressure. Okay, so for any substance at atmospheric pressure, this temperature at which solid and liquid phases are at equilibrium with each other, we will be calling it as the melting point or freezing point of that substance. Try to understand this. Okay, at melting point or freezing point, the solid and liquid phases will be in equilibrium at the atmospheric pressure. Okay, so what we can understand here is that the system is in dynamic equilibrium. Both the opposing processes are happening. They are happening simultaneously and they are happening at the same rate. So the amount of ice and water remains constant. Okay, that is the meaning of solid liquid equilibrium. Now, if I talk about liquid vapor equilibrium, for that we have taken an example. Okay, so firstly we have taken a transparent box which is having a U-tube with mercury. We call it as manometer. Okay, manometer is used to measure the pressure. All right. So we have put a drying agent, that is calcium chloride, or you can take phosphorus pentoxide P2O5. Why we are taking it? We want to dry this box. We don't want any vapors also. कि अगर कोई भी vapors हो or any water vapors are present, it will absorb all the moisture. This drying agent, okay, this is a drying agent. So it will absorb all the moisture because we don't want any moisture abhi. Okay. Alright, so for few hours we will be putting it. So once we once it is dried, we'll remove the drying agent by tilting the box on one side, and a watch glass containing water is quickly placed. So we'll quickly put it ताकि कोई vapor ना आए उसमें. Okay, so we'll quickly place the water like a petri dish having water in it. Okay, so you will be observing that the mercury level here, just see the mercury level here, and here in the right limb the mercury level will increase. Okay, now it is slowly increasing and finally it will attain a constant value. Why it is increasing? This mercury level increases because the pressure here inside this box has increased and then it has reached a constant value. And यहाँ पर जो volume है, the volume of the water will also decrease. Why? Because evaporation will happen, right? Water will get evaporated. So slowly the pressure will increase. Now what the pressure, why it is increasing? Earlier there were no water vapor, हमने सब dry कर दिया था, right? Or very less. So when water started getting evaporated, okay, addition of यहाँ पर water vapors हुई. Okay, so water vapors now they are present inside the box. All right, so because of that the pressure started to increase. The pressure is actually the vapor pressure. All right, we will be calling it as a vapor pressure. Okay, fine. So what will happen ki this increase in pressure happening, but it will start decreasing with time because जब evaporation होगी तो condensation will also start. Okay, So a condensation will also start, and finally after some time a condition will happen, an equilibrium state will be reached where there will be no net evaporation. Okay, means because the rate of evaporation will be equal to the rate of condensation. So no net evaporation will happen. That is why the pressure has now become constant. Okay, that's why it is not changing, and we can represent this equilibrium like this. So it means that now the liquid and the vapor phase are in equilibrium with each other. Okay, so what we can say is that at equilibrium, the pressure exerted by the water molecules at given temperature will be constant, and it will be the vapor pressure of water, and vapor pressure will increase with increase in temperature. But when the watch glass is open to the atmosphere, okay, rate of evaporation will be constant, but now the molecules are dispersed into large volume of the room, so the rate of condensation will be less than the rate of evaporation. Okay, so in the case of open system, it won't be possible to reach the equilibrium. So from here we have understood one thing which is very important, ki equilibrium state can be achieved in closed system, or you can say isolated system. Okay, it's not possible to achieve equilibrium state in an open system. All right. So water and water vapor, they will be in equilibrium at atmospheric pressure, which is 1.013 bar and 100 degrees Celsius. Okay, that too in a closed vessel. All right, not in an open vessel. So the boiling point of water will be 100 degrees Celsius. All right. So just like we have defined the melting point, same way we can define boiling point, that for any pure liquid at 1 atmospheric pressure, the temperature at which liquid and vapor are at in equilibrium. Okay, so at boiling point, the liquid and the vapor phase will be in equilibrium, and the boiling point will be depending on the atmospheric pressure. So you know that it depends on the altitude also. We have learned it in lower classes. At high altitude, because of low atmospheric pressure, the boiling point also decreases. Okay, so that is about the liquid vapor equilibrium. Now you know students ki solid also sublime sometimes directly converts to vapor. Okay, so again if we take an example of iodine, iodine is a sublimable substance. So if we place it in a closed vessel, after some time you will see that the vessel will get filled up with violet vapor, and the intensity of color will increase with time. So after some time the intensity will become constant, means that color, see we have discussed na koi bhi observable property ho sakti hai, this time we are taking color. So that color, intensity of the color will become constant, means now the state of equilibrium has been reached. Okay, ki the solid iodine sublimes to give iodine vapor, and the iodine vapor condenses back to give solid iodine. Okay, or it's not condensation, actually it's deposition. Okay, when gas directly converts to solid. So the equilibrium, we can represent it like this. So this was during the phase change. Okay, now let's say if I am talking about dissolution of solids or gases in liquids, then what happens? Dissolution means ki jab I am dissolving solid or gas in liquid. So you know that we have already discussed, we have studied the whole chapter solutions. Okay, we know that only a fixed or limited amount of solute, or let's say sugar or salt, is you can say can be dissolved in a given amount of water at room temperature. Okay, but if we make a thick sugar syrup by dissolving sugar at high temperature, अगर हमने temperature बढ़ा के उसमें ज़्यादा sugar dissolve कर ली, okay, but if I again cool that, if I again cool that syrup to room temperature, what will happen? Sugar will separate out, sugar crystals will separate out, crystallization will happen. So we call it a saturated solution when no more solute could be dissolved at a particular temperature. Okay, so the concentration of solute in a saturated solution depends on temperature. This is the main thing, that it will be depending on the temperature. So what is happening in a saturated solution? Dynamic equilibrium is happening. अब dynamic equilibrium कैसे है? That the rate of dissolution of sugar will be equal to the rate of crystallization. कि जितनी dissolve हो रही है उतनी ही crystallize हो रही है. Okay, so that is the state of dynamic equilibrium. Okay, all right. So like we can do this thing, like we can take radioactive sugar and wahan se we can find out the equality of the two rates. Okay, so try to understand this. Now for gases in liquids, again for gases, when we dissolve gas in liquids, let's take an example of soda water bottle. When you open a soda water bottle or your cold drinks, okay, some of carbon dioxide gas, it fizzes out. Okay, you see a lot of fizz coming out. So that fizz is actually the carbon dioxide gas that has been dissolved. Okay, so this phenomena arises due to the difference in solubility of carbon dioxide at different pressure. क्योंकि जब we open the knob ना, pressure decreases and the gas comes out. Okay, so but under pressure what happens? There is an equilibrium between the molecules in the gaseous state and molecules involved in the, or you can say dissolved in the liquid. So you know we have already studied Henry's law, okay, in solutions. So you know that Henry's law states that mass of gas dissolved in a given mass of solvent at any temperature is proportional to the pressure of the gas. Okay, so the amount of gas dissolved is directly proportional to the pressure which we have studied, right? So this amount will decrease with increase in temperature. Okay, so you know with increase in temperature the solubility of gases decreases. So what happens in the case of soda water bottle? So it is sealed under high pressure when its solubility in water is high, but when you open it, the some of the dissolved CO2 gas will escape out and it will reach a new equilibrium condition for lower pressure. Okay, so that is how you can say ki after some time you see your cold drinks also, they turn flat, right? There is no fizz, nothing, because all of the gas dissolved in it has been removed. Okay, so it goes out. That is the thing. So what we can say for this physical equilibrium is that for solid liquid equilibrium there is only one temperature, that is melting point, where the two phases can exist. Okay, and there is no exchange of heat with the surroundings. The masses will also remain constant. For liquid and vapor equilibrium, the vapor pressure is constant at a given temperature. For dissolution of solids in liquid, solubility is constant at a particular temperature, but it will change with temperature. And similarly, you know, for dissolution of gases in liquids, the concentration of gas in liquid is proportional to the pressure. Okay, pressure of the gas over the liquid. So these are the points that we have generalized from our discussion. Okay, so now you will be thinking कि मैम इसमें से question नहीं आता, but it can be asked because it is mentioned in your NEET syllabus also. So it is important for us to learn about physical equilibrium. Okay, questions can be asked and it is actually our basic. So what we can say, this is the general characteristics of equilibrium involving physical processes. So what I told you, that equilibrium is possible only in a closed system. It is not possible in open system. Try to understand. Okay, both the opposing processes occur at same rate. There is dynamic but stable condition, so the equilibrium will be dynamic. Okay, all the measurable properties will remain constant at that time, and when equilibrium is attained for a physical process, it is characterized by constant value of one of its parameter. Okay, so one of its parameter would be constant. All right, and the magnitude of such quantities at any stage indicates to which extent the physical process has proceeded. Okay, so these are the conclusions which I can draw from these different processes. Okay, like for liquid vapor equilibrium, we know vapor pressure is constant at given temperature. For solid liquid, melting point is fixed. Okay, what we have just discussed, all these things are there. So this is about the physical equilibrium. Now we will be talking about the equilibrium in chemical processes. That is the main thing to be focusing on. All right, so we'll be again talking about dynamic equilibrium. Okay, so analogous to physical system, chemical reaction will also attain a state of equilibrium. Now, how? You know, some reactions, they can occur both in forward and backward direction. तो equilibrium कब achieve होगा? Equilibrium will be achieved when the rate of forward and reverse reaction will become equal and the concentration of the reactants and products remain constant. So at that time when the rate of forward and backward reaction becomes equal, the concentration will also be constant. This will be the state of chemical equilibrium. Okay, fine. Again, this is dynamic. This is not static, it is dynamic because a forward reaction is happening which is giving us product, and a reverse action is also happening which is giving us the reactant. So how to represent it? Let's say if I am having A plus B, they are combining to form C plus D. On the other hand, C plus D will again give back you A plus D. So forward and backward reaction both are happening. So class, hoga kya? What will happen? With passage of time, C and D will start increasing. Okay, there will be accumulation of C and D and depletion of A and B. Okay, so what will happen? जैसे जैसे सी एंड डी बढ़ना शुरू हो जाएगा एंड ए एंड बी की कॉन्सेंट्रेशन कम होनी शुरू हो जाएगी, देयर विल बी अ डिक्रीज इन द रेट ऑफ फॉरवर्ड रिएक्शन. ओके, बट नाउ सी एंड डी की कंसंट्रेशन बढ़ गई तो अब वो सी एंड डी हमें फिर से क्या दे देंगे? ए एंड बी. सो देयर विल बी डिक्रीज इन द रेट ऑफ फॉरवर्ड रिएक्शन बट इंक्रीज इन द रेट ऑफ रिवर्स रिएक्शन. ओके, so after some time what will happen? The two reactions will occur at the same rate and they will reach a state of equilibrium. Okay, similarly we can reach at equilibrium from C and D also, कि अगर हम C and D डालें तो it will form A and B. So again in that case also we will reach equilibrium. So you can see this. So earlier the concentration of A and B starts decreasing like this. Okay, and the concentration of C and D starts increasing. After some time you will see it will become constant. It is becoming constant and this is the state of equilibrium. Okay, so equilibrium can be achieved from both the direction. This is the state of equilibrium that we can represent. Okay, so now we know what is chemical equilibrium. Now the thing is that we need to understand about the law of chemical equilibrium. So let's say if we have a general reversible reaction, A and B are the reactants, C and D are the products. So there was some research done by some Norwegian chemists. Okay, so they actually gave us an expression for equilibrium constant. So this is what we call as equilibrium constant, which is denoted by Kc. Now Kc, why we are writing it as Kc? Now try to understand. We are taking the concentration of products divided by the product of concentration of reactant. So we are taking concentration. Now we are representing equilibrium constant in terms of concentration. So this C represents concentration. Okay, so it is also known as law of mass action because in early days of chemistry concentration was called active mass. So अगर आपसे law of mass action भी पूछा जाए, you should know this is the same thing. Okay, but what happens is if you are having another kind of reaction, let's say अगर stoichiometric coefficients हो, right? If we have stoichiometric coefficients, so in that case what will happen? We will see that. Okay, so let's take an example. H2 plus I2 gives 2HI. So if I want to write the equilibrium constant for this reaction, I have to take the concentration of product. Product is HI, so concentration we always represent in square bracket, you know that. Okay, divided by the concentration of hydrogen into concentration of iodine. But what is this 2 here? This 2 will go into the power, okay, in the exponent. This has been determined experimentally also. जब concentrations note करी गई, various expressions were written and this was observed to be the right expression कि if we put this 2 into the power then the observed concentrations are correct. Okay, So in that case, I can generalize this law, or I can generalize this equation of equilibrium constant as, let's see that. So here students, okay, this 2 will come under bracket, okay, here please note. So now what I can say, that this law will be equilibrium law, that is at a given temperature, the product of concentration of reaction products raised to the respective stoichiometric coefficient in the balanced chemical equation divided by the product of concentration of the reactants raised to their individual stoichiometric constant has a constant value. This is the law of chemical equilibrium. Keep that in mind. Now what is this telling us? It seems to be quite confusing. Let me clear it. So let's say if I'm writing the reaction as like this. So this is a general reversible reaction what I am taking, okay. So if this is a reaction between A and B with the stoichiometric coefficients that I am taking as small c and small d, okay. So according to the law of chemical equilibrium, the constant Kc will be equal to C raised to the power small c concentration of D raised to the power small d divided by A raised to the power A and B raised to the power B. So this is very important. Keep that in mind students. This is the equilibrium constant. Try to understand कि ये जो concentrations हैं, these are the concentrations at equilibrium, okay. These are the equilibrium concentrations की मतलब when equilibrium is reached, so at that time what is the concentration of your reactants A and B and products C and D, okay. And these are the stoichiometric coefficients. Concentrations are taken in mole per liter, and this is what you will be getting as the equilibrium constant, okay. Keep that in mind. Now let's say I'm taking an example, okay. So let's take an example. The reaction is 4NH3 plus 5O2 gives 4NO plus 6H2. Now please write down the equilibrium constant for this particular reaction. Try to write down in your notebooks, okay. So we will be taking the concentration of product, that is the equilibrium concentration of nitric oxide raised to the power 4 because its coefficient is 4. Similarly, the concentration of water raised to the power 6 divided by concentration of reactants, which is ammonia raised to the power 4 and oxygen raised to the power 5. Simple. So we have got the expression for equilibrium constant for this particular reaction. So I hope now you all have understood how to find out the equilibrium constant in terms of concentration, okay. So now there are few points I want you to understand. For that, let's take an example of this reaction, okay. So the reaction is H2 plus I2 gives 2HI. Now if I want to write the equilibrium constant for this reaction, let's say it will be HI concentration raised to the power 2 divided by H2 into I2. Okay. Let's say I am taking it to be X. This is X. Some value it is having, which is X. Now students, what if I reverse the reactions? Because the reaction is happening both ways, no? So if I reverse this reaction, means on reversing I can say, if I am having 2HI gives, means I am starting from HI now, the decomposition of hydrogen iodide to give hydrogen and iodine. Now what will be the equilibrium constant for this now? Concentration of products divided by the concentration of reactant here too. Now don't you think if I want to write it in terms of X, it is just 1 by X? Yes, Kc dash उसको लिख लेंगे, Kc dash. Or if Kc was X, so if I can write it as 1 upon Kc also. So Kc dash is 1 upon Kc. So what I have understood from here, very important thing, that when I reverse the reaction, the value of equilibrium constant will become reciprocal. Okay. It will become reciprocal of the original reaction. Now let's say I am multiplying this with any number. If you multiply it with any number, let's say I'm dividing it with 2. Okay, let's divide the reaction with 2. Okay, not this one, the original one. We have to divide the original reaction. That's what we are taking. All right. Yeah. So this was the original reaction. यहाँ पर लिखते हैं. Now I am dividing it with 2. Half H2 plus half I2 gives HI. 2 से 2 will cancel, right? Now write the equilibrium constant Kc double dash for this. So here it will become HI concentration and here concentration of H2. Power क्या होगी? 1 by 2 and here it will be I2 raised to the power 1 by 2. So can I write it like this? HI square upon H2 I2 whole की power 1 by 2. So if I write it as 1 by 2, this 2 will cancel out, okay, and I will get this expression only, okay. So this is our x or this is our Kc, right? So Kc raised to the power half हो जाएगा. So Kc double dash यहाँ से हमें क्या पता चला? Kc raised to the power half means जिस number से मैंने अपनी equation को multiply किया with the number which I have multiplied with the chemical equation, that number has gone into the exponent, okay. So that you have to keep in mind these two results. So let's say if I have to multiply any reaction with n, okay, so Kc n will be equal to, यहाँ पर we will be writing Kc raised to the power n, okay. So means it will become n times हो जाएगा, all right, like it has now become 1 by 2 times in this case. All right, students. So now students, we can generalize this, okay, what we have learned till now. So we will say कि for equilibrium constant for the reverse reaction, if we are talking about the reverse reaction, so it will be inverse of the equilibrium constant for the forward reaction, okay. Like here we have seen, like if this is a forward reaction, its equilibrium constant is K, then for the reverse reaction it will be 1 by Kc, okay. And if I multiply it with n, so it will become Kc raised to the power n, okay, it will go into the power. So that is what you need to know about the equilibrium constant. इस पे based questions are also asked, alright. So keep that in mind, how to find out the equilibrium constant Kc and what are the changes we do if we reverse the reaction or if we multiply it with some number. Okay. Now let us talk about homogeneous and heterogeneous equilibria. So students, homogeneous equilibria means, homogeneous means where all the reactants and products are in same phase. Same phase means, let's say if I'm having nitrogen and hydrogen, they react to form ammonia gas, okay, of course 2NH3. Now here you can see that all the reactants as well as the product is in gaseous phase or in gaseous state. So here this is an example of homogeneous equilibria ki all the reactants and products are in same phase in gaseous phase. Like here you can see here we are having ester plus water gives acetic acid and ethanol, okay. So what is happening in this case, all of them are in liquid state, and similarly here also all of them are in aqueous state, all right, or liquid state. So means they are in homogeneous solution phase. Now we need to understand ki for homogeneous reactions how we will be writing the equilibrium constant. So basically we will be talking about the gas phase reactions, okay. Equilibrium constant for the gas phase reactions ki in gases are we going to use the concentration or are we going to use any other factor for representing the equilibrium? That's what we are discussing now. So for that, let us take an example. So students, what we have discussed till now is that the concentration, the equilibrium constant we have represented in terms of the molar concentrations of the reactants or products. But for gas reactions or gas phase reaction, it is more convenient to use the partial pressure instead of the concentration. So we'll be using the partial pressure of the gases. How? Let's see. So you know that for an ideal gas equation, PV is equal to NR. T. So the partial pressure, it will be N upon V RT. So you know N is the number of moles, V is the volume, R is the gas constant, T is the temperature. So number of moles per unit volume, N upon V. N upon V ko what we can say? We can say concentration only, right? This is what concentration is, number of moles per unit volume. So I can say P is equal to CRT. So we can say ki if pressure is in bar, C we can take in mole per liter or more per decimeter cube, R is in again 0.813 and temperature is in Kelvin. So we can use that. So from here we can say that the partial pressure is directly proportional to the concentration of the gas. Yes. So instead of the concentration, I can use the partial pressure term in the equilibrium constant expression, right? That's what I want to tell you. Okay, instead of concentration, we can use the partial pressure. So for that, let's understand a pretty easy example. Let's take H2 gas plus iodine gas. They combine to form hydrogen iodide. Now this is a homogeneous reaction. So Kc for this reaction, what we know is Hi. Now I am writing gas also. Okay, raised to the power 2, of course, and here H2 gas and I2 gas. Usually we skip these terms gas, but to make you understand, I am writing it. So just now we have seen that the concentration of the gas is directly proportional to the partial pressure. So instead of concentration, I can write partial pressure of hydrogen iodide square divided by partial pressure of H2 into partial pressure of I2. That's what I can write now. Now what is this partial pressure? So now I have written it in terms of pressure. So it's now not Kc, it will become Kp. Okay, Kc was in the terms of concentration, Kp means in terms of pressure. So according to this equation, you know that the partial pressure of Hi will be equal to concentration of Hi into RT. Similarly, partial pressure of hydrogen will be concentration of hydrogen into RT. Same goes with iodine. It will be the concentration of iodine gas into RT, right? So if I put the value RT is like with RT here, so concentration of Hi into RT whole square, okay, because it's square na. So same goes here, H2 concentration RT into I2 concentration and RT. Now what do you think students? RT will cancel out, RT square hai yahan par. So again you see that Kp has come out to be Hi square divided by H2 into I2. Don't you think it is again equal to Kc? So for this particular reaction, Kp has come out to be equal to Kc. So I want to make you understand that Kp means when we are using partial pressure. Now it is not necessary that every time Kp will be equal to Kc. Let's take an example for that. So now let's take a reaction where hydrogen. Okay, let's take an example for the formation of ammonia. Let's say. Okay. So N2 plus, of course it is in gaseous phase, plus 3H2 gives 2NH3. Okay, so try to write down the value of Kc. So Kc will be NH3 raised to the power 2 divided by N2 concentration and concentration of hydrogen raised to the power 3. Okay, so this is then expression for Kc. Now write down the expression for Kp. So Kp is the pressure. Alright, so pressure of NH3 divided by pressure of nitrogen gas, NH3 raised to the power 2, pressure of nitrogen and pressure of hydrogen raised to the power 3. So write from here, I will be saying pressure will be equal to concentration of ammonia R square T square. Okay, I have written square also again. So pressure of nitrogen gas will be concentration of nitrogen into RT, and pressure of hydrogen gas will be the concentration of hydrogen gas into R cube T cube. So here also you will be getting cube. Okay. Now try to cancel it out. So in the numerator you have r square t square, and in the denominator you have r4 t4. Let's write it. So you have r square t square, and here you have concentration of nitrogen, concentration of hydrogen cube, and r4 t4. So it will cancel out, just divide it, and Kp will be equal to NH3 square upon N2 H2 cube r raised to the power minus 2 t raised to the power minus 2. So this much is your Kc. So you can say for this reaction Kp is equal to Kc into r to the power minus 2 t to the power minus 2. So that's what I wanted to explain you, कि in every reaction Kp won't be equal to Kc. So that will depend on the type of reaction we'll have. So what is the general representation, or you can say general relation between Kp and Kc? That's what we will try to find out now. So for that, let's take a general reaction like this only. A plus B gives C plus D. Okay, so for this reaction, what is going to be the relation? Let's see. So students, for this general reaction, I want to show you. Let's see how it is going to be written. So for this reaction, Kp will be equal to partial pressure of C raised to the power C. Same goes for D, and divided by A and B. So we will be writing in terms of concentration, because pressure of C will be equal to concentration of C into RT raised to the power C, right? So that will be there, and same goes for D. So RT may it will be added C plus D. Similarly here it will be A plus B. So now I can subtract that. So this will be your Kc. Okay, this will be Kc, and RT raised to the power C plus T and minus A plus B. Now this C plus D minus A plus B का मतलब क्या हुआ? We are writing it to be delta N. Now what is this delta N? Delta N is the number of moles of gaseous products. Okay, only we are talking about gas, keep that in mind. Number of moles of gaseous products minus number of moles of gaseous reactants. Okay, so by looking at the number of moles, you can try to relate the values of Kp and Kc, because in certain questions, such type of questions also have been asked in Neet. If you look at the PYQs, that for which of the following reaction Kp is not equal to Kc, or Kp is equal to Kc. So for there you have to see the number of moles. If the number of moles of products, gaseous products and gaseous reactants are equal, तो delta n की value in that case 0 हो जाएगी. Okay, so in that case Kp will be equal to Kc. So अगर number of moles equal है gaseous products and reactant के, let's say that example जो हमने देखा, यहाँ देखो number of moles of reactants, gaseous reactants कितने हैं? 1 and 1 2, and number of moles of gaseous products also 2. So delta n क्या हो गया यहाँ पर? 0. That is why here Kp is equal to Kc, right? So if you know this thing, you can answer this question. Alright. So this was about the homogeneous equilibria. If I am talking about heterogeneous equilibria, so again the system which is present in more than one phase, means if solid, liquid, gas, more than one phase if it's there. So your physical equilibrium, they are example of heterogeneous equilibria, like if you are having water and water vapor in a closed container, that's an example of heterogeneous equilibrium, right? And because here we have a gas phase and a liquid phase. Alright, so if you are having more than one phase, it will be a heterogeneous equilibrium. Now what we have to keep in mind, that if heterogeneous equilibria involve pure solids or liquids, so then what we will be considering, the molar concentration of pure solid and liquid will be constant. Okay, means that will be independent of the amount present. So the symbols, this means if you are having a pure solid concentration and if you are having a pure liquid concentration, you will be taking it as constant, whatever the amount of X is taken. But concentration in gaseous phase and aqueous phase will vary, so that you have to consider for the expression. So for solid and liquid, we will not be considering that. For example, if you are having calcium carbonate which is in a solid state, you heat it, it decomposes to give calcium oxide and carbon dioxide. So On the basis of this, what we have learned, Kc is this: CaOS means solid, concentration of carbon dioxide gas divided by concentration of calcium carbonate. Now calcium carbonate and calcium oxide both are in solid state, pure solid state, so their concentration will be constant. So constant, see, this is also a constant now. So if this is constant, these concentration are constant, so we can write a modified equilibrium constant. So it will be only dependent on the concentration of carbon dioxide, or if you want to write in terms of Kp, so it will be partial pressure of CO2. So in heterogeneous equilibrium, it's just that we have to keep in mind that for pure solids or liquids, the concentration will be constant, so that we will not be considering in the equilibrium expression. For example, the action between nickel and carbon monoxide to form nickel carbonyl. Now here we are not considering the concentration of solid nickel here. We are just considering the concentration of nickel carbonyl gas and carbon monoxide. Okay. So heterogeneous equilibrium के लिए there must be pure solids or liquids, however small amount that is present. Okay, that's not a problem. But the concentrations and partial pressures, they will not appear in the expression of equilibrium constant. For example, here the concentration of silver oxide and water is not appearing in the expression of equilibrium constant. Okay students, so I hope you have understood what is equilibrium constant, how to find it out, the relationship between Kc and Kp. Okay, that is important, how to find out Kc and Kp, and how to find out equilibrium constant in terms of the heterogeneous equilibria. So this was the most important topic from exam point of view. In starting, what we discussed was basics, important, but that was more conceptual. So the numericals will be asked, or questions will be asked based on equilibrium constant, so revise that. Okay, so please revise that, and in the next lecture we'll be talking about the applications of equilibrium constant. What are the applications, how we can use it in different types of reactions. Okay, so I hope for today's lecture everything is clear. Still, if it is not clear, please comment below in the comment section. Do like this video and comment if you are able to understand all the things or not, and if there is anything that you want me to explain again or focus more on. Okay, so please feel to write down your comments there. All right, and I'll be meeting you in the next lecture. So thank you so much students. Bye bye.